In this video we will talk about wormholes, and as shown in various science fiction movies, we will find out if such gateways to other worlds could really exist. So buckle up and enjoy.
Everybody ready to say goodbye to our solar system? To our galaxy. Here we go.
Hello and welcome back to Alex SpaceX Talks. Before we resolve the question if wormholes really exist, let me give you the theoretical explanation of it first. A wormhole is a hypothetical tunnel-like structure that connects two different points in space and time. The idea of wormholes comes from the theory of general relativity, which was developed by Albert Einstein in the early 20th century. In general relativity, space and time are intertwined, forming what is known space-time. According to the theory, objects with mass or energy warp the fabric of space-time, causing it to curve. This curvature affects the motion of other objects, including light. If two massive objects, such as two black holes for example, are positioned in such a way that their gravitational fields overlap, they can create a throat in the fabric of space-time. This throat could act as a shortcut, allowing objects to travel between the 2 points in space-time without having to traverse the distance between them. The 2 points may be in different parts of the universe or even in different universes altogether. Wormholes have been a popular subject in science fiction movies for decades, with movies like Star Trek, Stargate and most recently Interstellar. One of my most famous science fiction movies, however, that deals with wormholes is Event Horizon. The movie tells the story of a spaceship called the Event Horizon, which was designed to travel through a wormhole and emerge in a distant part of the galaxy. The ship disappeared during its maiden voyage, and after 7 years, a distress signal is received, indicating that the ship has reappeared in a decaying orbit around Neptune. Taking Event Horizon as an example, one way to visualize a wormhole is to imagine a piece of paper with 2 points on opposite ends. If you were to fold the paper so that the 2 points meet, you would create a wormhole.
Imagine for a minute that this piece of paper...
No, excuse me, that's Vanessa and that's mine.
Attractive piece of paper represents space-time, and you want to get from point A here to point B there. Now, what's the shortest distance between 2 points?
A straight line.
Wrong. The shortest distance between 2 points is 0, and that's what the gateway does. It folds space so that point A and point B coexist in the same space and time. When the spacecraft passes through the gateway, space returns to normal.
Wormholes have captured the imagination of scientists and the public alike because they could potentially provide a shortcut for space travel. Instead of traveling vast distances through space, a spaceship could enter a wormhole and emerge at a distant location almost instantaneously. However, the practicality of using wormholes for space travel remains unknown, as the conditions required for their existence are still not fully understood. There are many challenges to using wormholes for travel. For one thing, wormholes are incredibly unstable and can collapse at any moment. Additionally, we would need to find a way to stabilize a wormhole long enough for a spaceship to travel through it. We would also need to find a way to enter and exit the wormhole safely without being destroyed by the intense gravitational forces involved. There is currently no direct observational evidence for the existence of wormholes in our universe, and it remains a topic of theoretical speculation. The reason for this is that wormholes would require the existence of exotic forms of matter that violate the known laws of physics, such as negative energy densities and negative mass. While there have been proposed experimental setups to try and create or detect wormholes, they are largely hypothetical. Additionally, even if a wormhole could be created, it is currently unknown how it could be stabilized or used for practical purposes. Like the video so far, then please hit the like button, subscribe to my channel if you haven't already, and hit the bell to get notified whenever I upload a new video. Your support and appreciation of my content is what motivates me to continue with my channel Alex SpaceX Talks. What is the difference between a wormhole and a black hole? Black holes and wormholes are both concepts in astrophysics that involve the bending of space-time. However, there are several key differences between them. Black holes are formed by the collapse of a massive star or the collision of two massive objects. Wormholes, on the other hand, are hypothetical structures that are not known to form naturally. It's once again important to note that wormholes are purely hypothetical structures that have not been observed or detected, whereas black holes have been observed indirectly through their effects on nearby matter. While both concepts involve the bending of space-time, they have distinct characteristics and are subject to different theoretical and observational challenges. Nevertheless, the idea of wormholes remains a fascinating topic in theoretical physics, and it continues to be studied and explored as a possible solution to some of the most fundamental questions in cosmology and the nature of our universe. And that wraps up today's video about wormholes. Thanks for tuning in, and we'll see you in the next one. Ciao!